Assalamu alaikum. How are you, students? I hope you are doing well. So today we are going to learn about SUVAT equations, SUVAT. Now before I begin my lesson, I want to ask you guys if you know about anything about these equations. If any one of you has the answer, please raise your hand using that meeting. No one? Okay, let me explain it to you. Pay attention here. So S represents distance or displacement. U represents the initial velocity. V represents the final velocity. A is the acceleration and T is the time of the motion or time of the journey. All these variables SUVAT are the physical quantities, and these variables are being used in these equations. That's why they are called SUVAT equations. These equations are used to define any kind of motion, and they can be used in any problem that involves the motion or kinetics of a body. So for example, this equation here involves a combination of 4 variables out of the 5 SUVAT variables. So S displacement, initial velocity, acceleration and time. Displacement, initial velocity, final velocity and time. So we have these equations to solve the motion related problems. Okay, now let's move on to the next topic, which is these are the basic trigonometric ratios, and they are very important in solving the questions in physics and mathematics. So we encounter these equations, or we need to use these equations, these ratios very frequently in IGCSE and A-levels questions. So let's have a quick review of them. They are very easy but very useful to remember. Sine theta, cos theta and tangent theta, they belong to a right angle triangle in which one angle is at consideration. So according to that angle, an adjacent side is called A or base, and opposite side is called O or perpendicular as well in some textbooks, and the remaining side, which is the longest side in the triangle, is the hypotenuse. Another way to remember the hypotenuse is to remember that they are opposite to the right angle, right? So these ratios are not but the ratios of the sides. Either two of them has been placed on one another. So sine theta is opposite side upon hypotenuse, cos theta is adjacent side upon hypotenuse, and tan theta is the opposite side upon adjacent side. Now let's move on, and please remember them. They are going to be used very frequently in your questions. Now these are some common or special trigonometric ratios. Why I call them special? Because whenever you have a question, for example, some question tells you that something is moving on a slope, and that slope is at some theta angle from the ground, or maybe a question that says that something is thrown at a certain angle theta, or there could be other cases such as in mechanical physics. There could be a rope holding a weight, and this could be the angle with the upper wall, the horizontal upper wall with the rope, theta. So these theta are usually 30 degrees, 60 degrees, or 45 degrees. They could be something else, but mostly or most commonly they are either 30, 60, or 45. So if we remember these special cases, which is 30, 60, 45, 45 degree right angle triangles, if we remember the trigonometric ratios of these special cases, then the problem solving will become faster and handy, right? So remember, for 30 and 60, the trigonometric ratios are alternatively interchangeable, right? Or we can say that they are alternatively equal, right? And tan theta is the reciprocal. In one, it is the reciprocal of the other. Now for the second case, which is the 45 degrees right angle triangle, and it is my favorite right angle triangle because in this one the adjacent and opposite sides are equal. So opposite side is equal to the adjacent side. And the second interesting thing is their sine theta and cos theta both are equal, and we do not have to worry about which angle are we considering. Any of the angles, either this one or this one, will give the same result, and tangent theta is equal to 1. So there is a 1:1 ratio between sine theta and cos theta in 45 to 45 degree right angle triangle. So this is a case which I like the most because I think this is very easy and make the problem easier. Now just remember these ratios and these relations. Okay. Now there is a special case of motion which is called the projectile motion. So projectile motion is any motion whose trajectory is like a projectile. So what is projectile? A projectile is an object that is thrown at an angle and travels under the influence of the gravity, and it continuously loses its y component. So for example, if you throw a ball, or if you throw maybe some ballistic, then it will move up and then it will become horizontal. It will move up, and then at some point it will stop moving up, and then it will go down until it reaches the ground. So this is a projectile motion, right? Now what are the properties of a projectile motion, and why does it move like this? It moves like this because of the gravity. The gravity does what? So for example, at this point, at this initial point, this is the y component of the initial velocity. U is the initial velocity, v is the final velocity, ux is the x component of the initial velocity, and uy is the y component of the initial velocity. So under the influence of gravity, if we make a tangent here, right, like this, under the influence of gravity, you can see that the y component will become less and less, while the x component will remain the same. So x component will always remain the same, but y component will get smaller and smaller. So previously the y component was this much, and now it is this much. and at the maximum height it will become 0. Why does this happen? This happens because of the influence of gravity, but the x component will always remain the same. So at every point Vx will be equal to ux. So the initial velocity, the x component of the initial velocity will always remain the same because there is no opposite force that is retarding it. Okay, so it will always move with the constant velocity. The second thing about this is the maximum height. The maximum vertical distance is known as the maximum height in projectile motion, and the maximum horizontal distance is known as range in the projectile motion. So delta S in this case is range, and the horizontal component is adjacent to the angle theta, so that's why it's known as u cos theta. It's equal to u cos theta, and the vertical component is equal to u sin theta because it is opposite to the angle theta. Opposite to the angle theta, this is angle theta, right? Now we have some general equations for horizontal and vertical parts. So for horizontal, final velocity is always be going to be equal to initial horizontal velocity, and the vertical final velocity will be using the second SUVAT equation. So we need the vertical component of the initial velocity minus gt. Now why is there a minus sign? There is a minus sign because we throw the ball above, or we throw the object, the projectile object above, and going above is basically going against the gravitational acceleration, which is downwards. So anything moving against the gravitational acceleration will get a minus sign. So that's why there is a minus sign. Okay, so gravity, it shows that gravity is acting against it. And for the horizontal distance at any point, maybe at this point or at this point, any point. So for example, the horizontal distance at this point, if the time for this point has been given, then the horizontal distance will be equal to this value. And for the vertical height, we need time as well as we need the y component of the final velocity, so we can work out the height of the projectile at that certain time. Now at this maximum height, the y component is 0, and if only the time has been given, we can work out the height, right? Now let's move on to the questions. Let's solve a question related to motions and projectile motion. So the question here, it says that a ball is kicked from a point P on the level ground. This is point P. The ball initially travels at 45 degrees. So the angle of projection here is 45 degrees to the horizontal. The ball reaches its maximum height after a time of 2 seconds. So now they have given us the time when it reaches the maximum height, time at this point. Air resistance can be ignored, so it means there is nothing that can retard the horizontal motion. So horizontal motion will be at constant velocity, right? So we do not have to worry about the horizontal component. Now they are asking us what is the displacement of the ball from point P until when it reaches the maximum height. So from point P to its maximum height, which means this distance, right? This is delta S in this case. So from the summary of the equations, we saw that the delta S is equal to uxt if the time is given. Ux is the initial velocity's x component, So we have the time, delta S equals uxt. Now we have the time, we only need to find this ux. Now since this is a 45-degree angle, and if we divide this vector of initial velocity into its vertical and horizontal components, they are going to be equal to each other, because in 45 degrees right angle triangle, the adjacent and the opposite sides are equal. So both sides are equal to each other. So both vectors are going to be equal to each other as well. So ux is going to be equal to uy, right? So if we find out uy, we can work out ux as well. Now we know that at maximum height vy is equal to 0, and we can use the second SUVAT equation, which is v is equal to u plus at, and in the case of projectile motion it is going to be vy is equal to uy minus gt. Now since vy is 0, uy is going to be equal to gt, and g is 10, t is 2. So the answer for uy is going to be 20 meters per second. So the vertical component of the initial velocity is 20 meters per second, and this vertical component is equal to the horizontal component as we discussed earlier. So it is going to be equal to ux equal to 20 meters per second. Now delta s, I should change the color to write the final things. So delta s is nothing but 20 multiplied by 2, which is equal to 40 meters per second. So this is our answer, part answer B. Hope you understand. Thank you.